Okay, hey, 2.3 for Algebra 2 focus of a parabola. And I guess the first thing to understand is what is a focus and what is a directrix. So we've dealt with parabolas, we've talked about vertex and standard form. We're now going to talk about a graph of a parabola and what a focus is and what a directrix is and how to graph and write equations using those. So when I look at this, this is my picture. Oops, let's try this again. Okay. And I'm going to go ahead and just hit play here. I've done a quick video. And you'll notice that this line that keeps moving around here, from the focus, which is a set distance from the outer edges of a parabola, so as we move a point around the parabola, that set distance is always going to be congruent to a set distance that's on the edge of the parabola to a line outside of the parabola. Okay, well, this set point out in here is called the focus, and this point, or this distance out here, or excuse me, this line outside here is called the directrix. Okay, and so directrix and focus. We've labeled the focus, but there you got it. So I'm going to go ahead and hit play again here, and I just want you to notice how those lines appear to stay congruent. I know that we don't actually see the measurements with them, but they appear to stay congruent as it moves it. Okay, and notice that line, as we move it around, is always staying perpendicular to the directrix down there. Okay, so it's a set point on the inside called the focus, and it goes to the outer edge, hits the parabola, and then it goes down to the directrix at a right angle. These lengths are always congruent. So this is always congruent to this. Okay, so that's what we're dealing with here. And these have properties as well. Just so you know, if I were to bring in, or excuse me, if I were to have, I don't know, a satellite dish of some sort, which is a cross section of it is a parabolic curve. If I were to have something hitting from the center of that, or from the focus on that parabolic curve to the outer edge, it could hit this parabola and then push outward at a straight line, okay? A line that would be perpendicular to our directrix. And if I were to continue to move that, so say I hit it here, I would have this ray pushing outwards that way. If I were to continue to move it here, I'd have a ray pushing outward that way. And so what it allows me to do is it allows me to focus whatever I'm trying to push out at a specific area. Okay, and that's kind of how our focus works there. So all of these rays just push outward at the same, at the same point. So you know, it's very handy, and the other is true as well. So you could bring rays in, hit the parabola, and focus. You can bring in waves. So let's say it's a satellite, and we bring in something, and it comes in to here, hits, and then focuses back to here. So you could have things coming in as well, focusing and coming back in to a set point. So it's very useful, especially when you're dealing with conic sections. Okay, and I'm going to just kind of messy here, but that's what ends up happening with this. So just a little background. So what we're going to do is we're going to go ahead and look at the different forms. There are 4 different forms. Okay, if we're writing in terms of y equals ax squared, we're gonna leave b. You know, if you have bx plus c. Well, what we're going to do is we're going to leave b as 0 right now and c as 0. So we're just going to kind of forget about this stuff for now. Just focus in right here. Okay, and notice that a has been replaced in all of these with 1 over 4p. So the 1 over 4p, that's our a term. Okay, and so what we could have is we could have a y equals 1 over 4p x squared, or y equals 1 or ax squared. Y equals negative 1 over 4p x squared. So if you think of it, that'd be like y equals negative ax squared. This would be y equals ax squared. Okay, this would be, notice this one says x equals. So x equals, whereas like this parabola right here goes upward, this parabola is going to go downward. Well, anytime you have an x equals y squared, okay, x equals, keep hitting my touch screen here, excuse me, x equals y squared, that parabola is going to open sideways. And this parabola right here is going to, since it's a negative, x equals negative y squared, that parabola is going to open sideways as well. Okay, but it's going to open to the left. So you're to think of an xy axis. Okay, it's opening towards the negative end of x. Whereas think of an xy axis. This is opening towards the positive end of x. Okay, this one, xy axis, is opening to the negative end of y. And xy axis, this one's opening to the positive end of y. Okay, so that's what we're dealing with here. So what we're going to do is we're going to go ahead and look at some equations and write some equations and kind of evaluate or put them on a graph just to see what, or pieces of them on a graph. So let's going to go ahead and start with y equals 1 over 4px squared. So that's like your y equals ax squared. It's the positive. It opens up. It's probably we're used to. Your focus is always 0p. Okay, and p meaning the distance from, say, like your focus. Let's say our focus was here. This length right here would be considered p. And that length is identical to the length down to here, which would also be considered p. And down here you'd have the directrix. All right, so we have the focus, the directrix, they're all the exact same distance. They're both the exact same distance away from our vertex. And that distance we call p. So if we go back to this picture right here, notice how, remember this point from our focus out to the parabola down to the directrix, those are identical. Okay, well, if I were to hit play here and bring that back to, say, like, oops, bring it back to right there. This length is p, and this length is p. Okay, and so I'm going to erase some of these things. Okay, so these two lengths from the vertex out to the focus is a length of p, and from the focus or the vertex down to your directrix is also a length of p. All right, and that's what we're utilizing here. So here we're saying it has a vertex of 0, 0, so I'm going to label that. It has a focus of 0, 2, so I'm going to label that. All right, so if I actually want to write an equation, I can actually use p in here because I know that a is equal to 1 over 4p. Okay, and I know I'm in the form of y equals ax squared because when I look at the parabola, it's open and upward. The vertex is 0, 0, and the focus is always contained within the parabola, so it's in the middle here. Okay, so it's above the vertex, therefore the parabola is opening upward. And so when I actually want to find a, here, I'm going to say, well, a is equal to 1 over 4 times 2, because p is 2. Length of from 0 to 2 is 2. So 1 times 4 over 2, or 1 over 4 times 2 is 1 over 8, which is our A term. So we have y equals 1/8 x squared. All right, well, let's try another one here. This one says write an equation of the parabola. This time the focus is at 0, -4, and the directrix is y equals 4. So you notice the focus is below the directrix. Okay, so I'm going to go ahead and just put the focus down here. We'll go 1, 2, 3, 4. Focus 0, -4. Directrix 1, 2, 3, 4. Y equals 4. And so without even graphing the parabola, even though we have a parabola on there, we can know where what's happening. It has to be opening downward. Has a p-value of 4. And p is a distance, so it's never negative. Okay, and this is also 4. And so if I'm going y equals, I know this is a -ax squared. It's opening downward. And I know that a is equal to 1/4p. And in this case, that's 1/4 times 4, which is 1/16. And so I have y equals -a 1/16 x squared. All right, so try another one here. This one says write an equation of the parabola. This time vertex is at 0, 0. And the directrix x is equal to -1. Okay, so I think I'll make -1 right here. Alright, so x equals -1. So notice my vertex is 0, 0, x is -1. That means my focus has to be the same distance away. So since this is a length of p equals 1, I've got to go this way 1 unit, same distance. So my focus is right there. So I have 1, 0 for my focus. Okay. All right. So if I want to actually write this equation, this is going to be not an x equal or a y equals, but it's going to be x equals a y squared. And a, once again, is equal to 1/4p, which is 1/4 times 1. P is 1. That's 1/4. So since that's an x equals form, x equals 1/4 y squared. So I know I have the parabolas drawn on here, but even if I didn't, just by putting the vertex and the directrix, it allows you to see which way the parabola is going to open, which tells you the form you're in. So if you recall back to what we did originally, we said, well, this is which way the parabola is opening, and this is the form we're in. That's kind of what you're doing at the beginning there. All right, one more. This one says, or at least one more before we start some transformations. This one says a focus at -2, 0. So I'm going to go to -2, 0. Let's just go ahead and put it right there. So f is -2, 0, which means my directrix has to be over here at x equals 2, and they even tell us that, I guess. And our p term, our p value then, p equals 2. And so when I'm writing the equation, this is a y, or excuse me, an x equals a -a squared, or a y squared. Okay, because it's opening sideways, our focus has to be contained within the parabola. So a is equal to 1/4p. P is 2. So that's 1/4 times 2, which is 1/8. And so we have x equals -1/8 y squared. All right. Now, before we finish this, we actually have to do some different transformations. So now we're going to take our a term, and we're going to translate our graph to the right or left and up or down. We're going to do that for each of our different a terms. So we have our y equals positive a, y equals negative a, x equals positive a, and x equals negative a. So remember our pictures. Opens up, opens down. Those are our y equals. Opens left, or excuse me, right. X equals positive a, and opens left. X equals negative a. Okay, so let's go ahead and look at this. And I gave us some different grids to kind of help out here. But in this case, identify the vertex, focus, axis, symmetry, and directrix, and then graph the function. Okay, so the first thing I need to do is identify the vertex. The vertex, remember H and K. Okay, so since it's y equals, this is my H term, which means HK is my vertex. Okay, and so H is 3, K is 1, so my vertex is 3, 1, so I go 3 and 1. There it is. And then my axis of symmetry is pretty easy to find once I know my vertex, or vice versa. My axis of symmetry in this case is x equals 3. It's the same as the vertex, so it runs this way, or it's on the same x value of the vertex since my graph is opening upward or downward. X equals 3. Now my focus is going to be 3. Notice these three values are always the same. And then I am at 1, but I'm going to have to move upward because this graph opens up to positive a. So y equals positive a, so it opens up. So my focus is going to be above my vertex. And so what ends up happening is I actually have to find my p-value, which p is equal to, in this case, well, it's kind of hard to tell. So let's actually say, well, I know that a is 2, and a is also 1 over 4p. So if that's the case, 1 over 4p has to equal 2. And I'm going to put it as a fraction because then I can cross multiply. And I know that 1 times 1 is 1, 4p times 2 is 8p. So p is 1/8. If p is 1/8, that means if I move 1/8 of the unit up from my focus, so 1/8 is half of a quarter, so here's a half, here's a quarter, so about right in there. Whoops. Okay, that is going to be my focus. And that's going to be at 3, 1, and 1/8. Right there. Maybe we should switch up colors. Which that also means that we were able to find our directrix pretty easy now. You know what, let's rewrite this. This will be 3, 1, and 1/8. Okay, so my directrix let's kind of clean that up. Is going to be equal to what my y value and my vertex was. So in this case, I have y equals 1, but I don't go up 1/8 from here. I have got to go down 1/8. That's minus an 8. So it's y equals 7/8. That's my directrix. There's my focus. Okay, so I have 7/8, which is like right about in there. Okay, there's my directrix about y equals 7/8. All right. And so if I wanted to graph it from here, really I've got the focus and the vertex or the directrix. The graph really, let's go ahead and switch up colors again. I'm going to go ahead and plug in, say 4 and that's going to give me, so if I put 4 in up here, 4 minus 3 is 1, squared is 1, times 2 is 2, plus 1 is 3. I have the ordered pair 4 and 3. Put there and reflect it there. So my parabola is going to do something like that. Now I could actually plot a few more points, but there's my parabola. You'll probably want to be more accurate, plug in a few other values, so maybe what 2.5 was and 3.5 was, but for the sake of what we're doing, I think I'm going to call it good there. Alright, so the next one, we have identify the vertex, focus, and axis of symmetry and directrix of this graph. So really quick, the vertex is 4, or negative 4, because that's a plus in there. So negative 4, 6. Axis of symmetry then, since it's a y equals, in this case it's a negative a, it's opening down. So its axis of symmetry is still going to be x equals negative 4. And if you recall from our last one on our focus had the same value here, here, and here. So this is also going to be negative 4. Okay, so and we have to find our p-value again. So again, a is 1 over 4p, which in this case a is negative 1/2. So therefore, I'm going to ignore the negative. I'm just going to look at the 4p. So I'm going to ignore that minus sign here. So I'll erase it just to get rid of confusion. And so since 1 is the same on top, really 4p has to equal 2. And if 4p equals 2, then p is equal to 1/2. It's just a coincidence 1/2 and negative 1/2 are there. So I'm going to start at 6, and this time the focus is going down because our graph is opening down. So the focus is moving down from the vertex. It's going downward. So I'm actually going to subtract 1/2, meaning my focus is at negative 4, 5.5. Okay. And since it's at negative 4, 5.5, the directrix is actually moving up. And so this is y equals, in this case, it's going to be 6 plus 1/2. So start at the vertex, or excuse me, start at the vertex and add 1/2. Go upwards, so y equals 6.5. Okay, so plotting these things, I'm going to go ahead and put my vertex in negative 4, positive 6. So negative 4, positive 6. There we go. And axis symmetry, x equals negative 4. Okay. And focus, negative 4, 6, or 5.5. So negative 4 and 5.5. Looks like 5.5 will be right there. There's our focus. We'll label that as our vertex. Okay, and our directrix is at 6.5. Well, that would be right here. And that's y equals 6.5. Okay, and then, well, our graph, if I were to put in, say, like negative 2, if I were to plug in negative 2 for x, that would give me 2 squared is 4. Half of 4 is 2 times negative 2 plus 6 is 2 plus 6 is 4. So when I plug in negative 2, I get an output of 4. And we can reflect that point over. And I could plug in 0. And if I plug in 0, I'd actually get negative 2 out. So that'd be like way down there. So this parabola is going to do something like that. Give myself enough room to graph tons, but I've got it. All right, so try another one here. This one, notice that the x equals positive a, so the graph is going to open sideways. Okay, and so when I look at this, I know my vertex. Notice in this case we have x minus k, or y minus k. So h is on the outside now. So when I look at my vertex, my h value is negative 6. k value is actually positive 4 inside. And so it's backwards. When you have an x equals, it's y minus k plus h. So it's kind of backwards from your normal one where you have y equals a times x minus h squared plus k. So since x and y switch, h and k switch as well. Okay, so make sure you make that note. So that's my vertex. My focus then is going to be, well, actually, you know what? Before I do my focus, let's put in the axis of symmetry. Okay. So my axis of symmetry. So since it's sideways, it's going this way. So this is going to be a y equals, and it's the same as this value. So y equals 4. Okay. And so when I'm looking at my focus, in order to find the focus, I have to know what P is. And to find P, I got to use A again. So A is equal to 1 over 4P, and it's also equal to 1/8. So notice ones are the same on top, so 4P equals 8. So P is equal to 2. So if P is 2, that means my focus would start at -6, and then we go 4, or excuse me, not -6, 4, it'd be -6, and since my vertex, you know what, let me graph these so I can show it here. Let me put on my vertex, so -6, 4. Okay, and my graph is opening, and I'm just going to do, even though this isn't the actual graph, my graph's going to do this. So since this is different, notice I have my axis of symmetry, y equals 4. My focus is going to be in here somewhere. Okay, so it's actually sliding this way, so it's actually going -6 plus my p term, plus 2. Okay, so that's why I kind of sketched that in real quick just so you can see that. Now this stuff is not accurate. That is. Okay, so that's my vertex. Okay, so my focus is at -6 plus 2 and then 4. Okay, so that actually means that the, oops, gotta fix that. That actually means the focus is at -6. Oops, that is not -6. It's -6 plus 2, which is -4. And 4. So we've got our focus. We'll label that with an F. Okay, and then the directrix actually goes back from there. So we take directrix and we'll say that's equal to x equals. So it's going to run up and down, and it's actually going to take the -6 we were at, and we're going to subtract 2 this time. So it's going to be x equals -8. Alright, so it's this line right there. X equals -8. Alright, so we got all of our pieces. Now we just need to graph it. So if we start plugging in values, so you know, I could plug in say -5 for x, and I would get 1 out, so about 1 out, right about there, and give me about there. I can keep graphing here, go 1 about there, oops, and if I would put in -4 about right in there. So you got to plug in a few values on this one. This one really flattens out pretty fast here. Alright, so you get a parabola that's really kind of flat. Okay. And we should be, it's 1/8, so it's not going up really fast there. Alright. And then one more here where we have y equal, or x equals -1/4, so -a, so it opens up like this. Okay, so once again, vertex. Vertex is going to be 4, 6. So hk. Well, this one's k now, and this one's h. Okay, got that over there. Axis of symmetry. Since it's like this is going to be my axis of symmetry running down the middle, so it's going to be a y equals. It's y equals 6. The same values. And then when we deal with the focus, our focus is going to be 4. In this case, we're actually going this way to get to our focus. So from our vertex, which is here, we're going to be subtracting. So 4 minus p. We have to find p. So using a is equal to 1/4, which is equal to 1 over 4p. So in this case, p equals 1. And so we subtract 1. And we have 6. Notice all three of these, once again, were the same. So my focus is actually 3, 6. And my directrix is taking x equals, and it's starting at the 4. And so we're moving this way towards the positive side for the directrix. And so that is going to be plus 1. So x equals 5. So plotting all those pieces, 4, 6. There's my vertex. Focus, 3, 6. There's my focus. My axis of symmetry. Y equals 6. My directrix, x equals 5. And then from the vertex, my graph, go over 1 1/4, there, and there, and there. So about there and there. So I get a parabola that does something like that. Alright, and we could keep graphing. I mean, my next point would actually be right there, I think, and right up there. So keep going if you wanted, but alright. Well, I think that's it. Good luck on those.